Morning. I'm audible to guys. Okay. So today we will just continue with the hashing techniques. Last time we discussed about hashing, so I hope everyone is clear about that. I'll summarize it a bit. Just wait, let me just share my screen. Okay. So last class we discussed about hashing. So what is hashing? Hashing is mainly um, it's also kind of data structure which is known as hash table. So in hashing, what we do, we just store data in our hash table, which is also kind of table or array, you can say. We just keep some keys, and those values are mapped to the hash table with the help of a particular function, and that function is known as hashing function. So hashing function is a mathematical function, and the selection of function will mainly depend on you. So in the last class we just gave a simple type of hash function. So in the last class, I just said the main idea of hashing was that whatever will be the key space or the values, we are going to store that value in that same index in a hash table. Correct? If value is 8, I'm going to keep it at 8. If value is 3, I'm going to keep it in 3, and so on. The main problem in this simple technique was that if we want to add some more numbers and our hash table is not sufficiently big enough, and moreover there are lots of empty spaces and those spaces are just wasted. So to solve that problem we need to find a hash function which will just minimize the use of your hash table or size of the hash table. So in this particular hash function, remember hash function can be anything. It will mainly depend on you. How efficiently you can select the hash function. It will depend on you. So in this example, I just selected a hash function which is using a modulus of size. So whatever will be the value, I'm going to divide that value with the size of the hash table. Then whatever will be the remainder, that remainder will be the index of the hash table where I'm going to store the particular key. So in this case, 8, 3, everything is known as key space. So if I follow this function, so what I do, if 8 mod of 10, the answer is 8. So I'm going to store the value at 8. General way, 8 mod 10, remainder is 8. So I'm going to store it in 8. Then 3 mod 10, I'm going to store it in 3. Then 13 mod 10, again it's a 3. So there's a collision. Okay, just keep this collision for a while aside. 6 mod 10, I'm going to keep it in 6. 4 mod 10, I'm going to keep it here. Okay, this is the, and 10, I can just store it here. The collision occur 3 and 13, correct? The problem is here collision will occur. So when collision will occur? When there will be the same key index generated using the hash function. That means a multiple value can be generated sorry, single index value can be generated from multiple number of key spaces. So it's not possible to find out unique index space for all of the key things or key numbers. So to avoid the collision, or the main goal will be to reduce the collision, okay, number of collisions. So there are two techniques for collision handling. One is chaining and other is open addressing. So chaining is also known as close hashing. Okay, so chaining, what happens in chaining? Instead of keeping it in the hash table, we just store the values in type of linked list. Okay, so here if 8 is the value, it's supposed to be stored here. I'm going to just use a node of a linked list and going to store the value in that linked list node, and I'm just going to use a pointer here. Okay, so similarly for the all the values, I'm not going to store in the hash table. Instead, I'm going to keep it here. So when 3 and 13 generates same index, which is 3, so I can just use another pointer and node. So first 3 was there, so I'm going to store 3 here. Okay, so next I found 13, so I'll take just another pointer and store that 13 in the next node. Okay, and so on. So all the values which will generate a same index, I can just put in that same index, but all the index will be again linked to a linked list. So in chaining, this is your chaining. This is a chaining process. In chaining, we just store everything in a linked list way. And searching 11. Didn't sort of. Okay, take us. Okay, I have a meeting, so I'll just do it fast. So this is chaining. I hope everyone is clear about chaining. So other option for collision handling is your open addressing. Okay, this is your open addressing. For example, this is open addressing. What is open addressing? In open addressing, if there is a collision, that means a space is already occupied by a number or key, then we are going to just store the value with the next open slots available. Okay, so since we just store the value in the next open space available, the names comes as open addressing. Okay, for open addressing we have different methods again. Okay, one is the very simple one is linear probing. Okay, linear probing means we are just going to store everything in a linear way. This is one of the simplest one. Okay, open addressing means, just remember the difference between chaining and open addressing. Chaining means we are going to store the value in a linked list, and open addressing we are going to store the value in the next open slot available or next empty space available. So in this case, first the same hash function we use, for example, so 8 was here, so in case of 3 and 13, 3 comes earlier, next comes 13. So since 3 is already occupied, I just stored 13 in the next available spot because 4 was just empty that time. I guess this part I already explained, so I hope you guys already know about this. So next available space was 13, so I just put 13 in place of 4. I hope everyone is following me. Is it yes? Okay, Dula said yes. Deepa, yes. Okay. 3 students said yes, Rohit, yes. Okay. So open addressing means we just put in next available slot. So one of the thing was method was linear probing. So what we do in the linear probing, we just slightly modify the main hash function. It will remain same. We will use this function, just a little modification, the hx plus fi, when there will be a collision. Okay, we are going to use this function only when we'll have a collision. For example, 13 uh, entry has a collision, both have the index 3, right? So means in normal way, I'm just saying I'm just going to store it in the 4 index 4 because that space is empty. But mathematically, how you can do with the help of this equation. So hx will be a plus of function of I is fi equal to I. Okay, this is the simplest function. Whatever be the I value, it will just give you the same I value, and I will start from 0, 1, 2, 3. And this index, don't confuse with the indexes of the hash table. I will always start from 0, 1, 2. So whenever you are going to calculate anything, you will just start from 0. If after using the 0 value, if you are getting a collision, then you will try the next value. Okay. So whatever will be generated value from this equation, that will be the index of your hash table. Okay, this is the equation for linear probing. So the whole equation you can also use like for all the keys as well, because we go to the next part only when the space is not available, right? So the problem with linear probing was that all the numbers are quite close to each other. Okay, that means it's a clustering problem. If all the numbers are just in a same place, it's in clustered in one place, it's a bit difficult or make some problem in future. Or you can see, just if everything is clustered just one place, then in other places there are lots of empty spaces, which is also not desired. We don't want this clustering problem. Okay, so for that, what there is another method which is known as your quadratic probing. Okay, so from the name itself, I hope you guys can guess the thing what's happening in quadratic. What will be the change? The equation is same, just there will be a little difference. Here for the linear probing, the equation is hx plus f of I. So this is linear. So if I am saying the function will be quadratic, so what will be the change? What's the main identification of quadratic? You guys think about it. Till then, I just draw the same thing again. Just think and tell me what's the main identification or characteristic of any quadratic equation when we say quadratic and when we say linear. Just simple. So give me the answer. Quadratic means 4. Linear means 1. No. Means, yeah, quad means 4, but quadratic equation, it has a special character. What's that? Just remember about the time complexity when it is linear. When I say it's linear, time complexity when it is quadratic. Yeah, I need to say something. Yes, 4 in a square form. Correct. So in case of quadratic equation, everything will be in a square form. So if this is a linear equation, ax square plus b is your quadratic equation. It is in terms of the square to the power 2. If I say ax cube plus b equal to c, then it's a cubic equation. The same goes for your time complexity as well. On linear time, on square, quadratic time, on cube is your cubic time, or on power n something x, or n power x is your exponential term, 2 power x. Okay, next to you are saying divided by 2. No, it should be very easier. So in case of linear, what was the equation? Hsx equal to hx plus f of I. This one will remain same, correct? The main function is just same. In case of linear probing, f of I was equal to I, correct? So if I am saying it's quadratic, your function will be just I square, correct? It's just quadratic. So in linear, f of I equal to I, and in case of quadratic, f of I equal to I square, and index will remain same. Okay, so if I am saying 8, hx function is still the same, hx equal to x mod size. Okay, it's the original function. So for 8, I'm going to store it in 8. Now if I say 3, I'm going to store it in 3, correct? Remainder 3. If I'm saying is 13, so what's the problem? What's the problem for 13? It's 3 again, correct? So just put it in equation. H dash 13 hx equal to, again same thing, just h of 13, f of, first you will go with 0 size, correct? Then what will be the answer? H of 13 what? 3. This one 0 square what? 0 again mod 10, answer is 3, but 3 is already occupied. So what he will do? He will do the next thing, h13 plus 5 of I will be 1 now, correct? And mod size, what will be the answer? H of 13 is 3. Now here it's 1. 1 into 1 what? I square 1, correct? So its mod size is 10. So for mod I'm going to store 13 here, correct? That's the answer. Now I have 23. Okay, again by normal thing, 23 mod 10, what will be the answer? It's again 3. 23 also points to 3. Now you have to see how to do it. H dash 23. Okay, 23 again same thing, 23 plus f of 0 10, correct? So first answer will be 3. Correct. 3 is already occupied. Correct. Next you will try with 1. If I use 1, then answer will be 4. 4 is again occupied by 13. Correct. Next option is what? 3. So if I do with 3, what will be the answer? You got it right. 0, 1 and already occupied. So next we have to use 2. Correct. Is it clear to you guys why 0 and 1 already occupied? 0 is already occupied. Answer will be 3. Next we use 1. 1 is also occupied. We use 13. So next is your 2. This one will be 23. And f of 2. What will be the answer? F of 2. 2 square. What will be the answer? 4. Now you tell me the answer. Where I should keep it? Oh, sorry, it's not 3, it's 3. H of 3 is 3. Remainder is 3. What's the answer? 4 plus 3 what? 7. 7 more 10. What? 7. So I'm going to store this 23. You are asking how it's? Yes, correct. So it's 23. So that means I'm going to store the 23 here in 7 position. Okay. Now again 4 more 10 is 4. Again you have to like do the same process again. For here 3 will be occupied and so on. So now you can say the keys are a bit distributed now. It's not clustered in just one position. Okay. So similarly, you have to find the values of all the keys. So quadratic probing comes just to avoid the clustering problem of your linear equation or linear probing. So only difference is that f of I will be the I square. Okay. Now if I say 43, what will be the answer? 43, again the index will be very high. Okay. Even in this case also, if I do it quadratic position, the size is only 10 and our numbers can go to very a bit different space or far place. So in that case, what? We need to find a threshold value. Okay. There should be a load factor maintained by the hash table. Okay. In quadratic equation also we will have the same problem. Means we need it means the difference between the keys will be in quadratically far. So if some numbers are here, some numbers will be there and some numbers maybe it's not even here. If you try with the 43, what will be the answer? 43 more 10, it will be 3. Again 3 is occupied, then you will start with this, then next available will be 3. Then 3 power 3 is what? 9. 9 plus 3, 12 and so on. So in this case also we will have the same problem. So they maintain a load factor. So what is the load factor? Load factor is total number of items stored if it's a dynamic hash table, then it's fine. They can just allocate it whenever needed. Okay. Other than that, it should maintain a threshold value for the load factor. Means you have to know, right, when we need to increase the size of the table, correct? So how will you find when to increase the size of the table? So you have to see the load factor of the table. So load factor is what? Total number of items stored by the size of the array. So if your load factor increases a threshold value or it exceeds a threshold value, we have to add some more memory, allocate some more space to our hash table. Okay, so you can say in all the things, somehow we are not going to get a constant time for searching the elements, correct? So every time we want to search an element, we can go to, like, if direct access, it's fine, but here I'm getting the collision here, right? Here I'm getting the collision for three numbers. So for three numbers, I have to find out the, wait, I'm getting collision. Hello. Oh, go ahead, Roba. Go ahead. It is second class, Roba. Question. Question. Ah. Okay, so the quadratic equation is for avoidance. I hope this portion is clear. So two types, apart from two types, there is the third part too. I guess there are some more types of open addressing thing. One is linear probing, other is quadratic. Second, we have already discussed. Third is the double hashing. Okay, double hashing is another method. মোৰ মিটিঙো আছে মই মিটিং কৰি আহি আকৌ এখন উলিয়াম ৰ So third one is double hashing. So double hashing, what we do is just a collision occurs. After collision occur, we just use a second hash function. Okay, so it's a hash of the hash function. So whatever hash function we are going to use, so same thing I will use. I'm going to use another hash function and that will be calculated in the next slide. So what is the main application of hash table? So whenever we will want, or it will be required that a constant lookup time or insertion time is required, we are going to use a hash table. Apart from that, to index data in a database, you use hash table. Again, in cryptographic applications, we use hash table. So hashing technique is a very important concept. You have to understand or remember. So other than that, there is a certain conditions for hash functions. Okay, how to select a good hash function. Okay, so these are the conditions to find a good hash function. So what is your should be the objective of your hash function? It should minimize the collision. There should be a uniform distribution of all the hash values and it should be easy to calculate. And it should be easier to resolve any collisions. Okay, these are the main characteristics of good hash function. Just remember 4 points. Minimize collisions. All hash values should be uniformly distributed, easy to calculate, and resolve any collisions. Okay, so this is all about hashing. So I'm going to stop it. Stop the class. I have to rush to the meeting. Okay, thank you. If you have any doubt, you can just text in the group. Okay, thank you. I'm ending the meeting for all.